we developed this recursive function repmult. That was from project 1.12 on page 31 of our text. And the goal was to create a general function that would give us a product that looks like this. Okay, so there are L factors. Okay, so there's and we can think of it as kind of like this is factor 0, factor 1, factor 2, factor 3, all the way up to factor L minus 1. So if we have from here we have 1 through L minus 1, and then we have the 0th factor, so that makes L factors altogether. And then they gave an example that repmult1526 will output all these factors multiplied together, which ultimately gives us this big number. Okay, and what we did was to build it up was we started with the we started with the answer, right, and kind of worked our way back. Then we said, okay, well, it's got to have these factors, which look like this, or are derived this way, and then we kind of expanded out these first couple of factors so that they would look more like the other ones. So we had 15 minus 0 times 2 minus 1 times 2, and then that looked like the rest of them, minus 2 times 2 minus 3 minus 4 minus 5. Okay, so that when L equals 6, our pieces that we our factors have a 0 times 2 through 5 times 2. Okay. All right. So then we went through a bunch of steps and we derived this general recursive function right here. So it's recursive because the name of it is repmult, and it calls repmult itself as it goes in. So in this video, I want to look at the same function, but from a little bit of a different perspective. So if you felt like you totally understood how repmult worked from the last video, you can skip this one. This is just, you may not have done recursive functions before, or this just might look unfamiliar to you. So I'm just doing a little bit of extra explanation for people who need it. So let's see. So yeah, so we ran all these tests, right? What I want to do with this one is I'm going to copy this, and basically, like, instead of starting with the great big problem here, the 1526, I'm going to start with a really simple problem, this 1520. Okay, and I'm going to take a look at it through the Python tutor that we've seen before. So pythontutor.com, and I'm going to scroll down to edit code and stick in my Python code. And what I'm going to do is start by looking at the 0 example, the 15, 2, 0, and see what happens when we step through that one. So this is a pretty basic one. Let's visualize the execution on that one. So we're going to come in. Let's step forward here a little bit. So the first thing we do is, we've created a global variable, this function here, repmult, okay, by using this definition. And now we're going to make a call to repmult. So let's go forward into that and see what happens. Okay, so that sets up this procedure right here with the variables, with n being 15, d being 2. So d is the difference between each factor, right? And then 0, L counts the number of factors, basically. So we're basically, by definition, we're saying that if there are 0 factors, give us a 1. And this makes sense in certain contexts. We're not going to worry too much about why we used a 1 here instead of a 0 or something like that, but I think that'll be clear as we get into further examples. So I'm going to step forward. Well, since L is 0 on our first call right here, we immediately go to return 1. So our return value is 1. And then we're done. Okay. I think for the next one, I'm going to edit this one. I think for the next one, I'm going to say print just so we can see the output. And make this a 1 this time. So now let's see what happens when L is 1. Okay, let's visualize this one. Okay, so now we go through, we create the function. We have the function set up now with these variables. Now it's n is 15, d is 2, and L is 1. So L is not 0 in this case, so we're going to go down to this step. So let's go forward. So now let's think about what's going to happen here. At this stage, L is equal to 1. So L minus 1, this L minus 1 here is going to be 0, right? 0 times d, well, d is 2. So 0 times 2 is 0, right? And at this stage is 15, so this is just going to be a 15. Okay, so this whole thing, this piece right here is going to come out to be 15. Then we're going to make a call to repmult, and we're going to call it with 15 and 2 and 1 minus 1, which is 0. So we're going to make a call, so we're going to make another call to 15, 2, 0. Now, if you remember from the last time, the result of this call, since this is going to be 15, 2, 0, the result of that call is 1. So we're going to end up multiplying 15 times 1, which is what we would expect if we had exactly 1 factor, if L was 1, right? So let's step through it and see here. So right now, like I said, this comes out to be 0 times 2. So 15 minus 0 is 15. So this should come out to be 15, and then we're going to kind of dive in now to this function and get a result. Okay, because notice we can't get a result until we get something back from something returned from this function. So let's step. So now it's the way to think of it is we're calling a copy of the same function. Okay. So first we were calling repmult with these 3 inputs. Now we're doing another repmult. We're running a different repmult that has these 3 inputs: 15, 2, and 0. Okay. So as we saw, when L is equal to 0, this is going to be true. We're going to return 1. And when we return 1, what happens? Well, let's see what it says. It says returned value is 1. So that means that this piece is going to be in this version of the function, in this copy of the function, this piece is going to be replaced with a 1, right? And again, in this copy of the function, this piece is 15. Okay, so we'll go forward. Okay, so now what that means was, so you see what happened. We were returning the 15 times the 1 here. And that gives us a return value of 15. So if I go forward and say print that, it prints a 15. Okay? Now let's try it with 15, comma, 2, comma, 2. Oh, I gotta go in and edit code for that. And let's think about what this is doing. If I say 15, 2. So we have our number is 15, right? And our difference between terms is 2. So the next term is going to be 13. And this tells us how many terms we're going to have. This says we're going to have 2 terms. So I should just have 15 times 13, right? And if we were going to write it out in terms of these L thingies, what we would do is say this is 15. Let me see. I want to write it the same way I did it in idle here. Where was it? 15. It would be this. So there's just going to be 2 factors. So basically factor 0 and factor 1. Okay, so 15 times 13. Or in other words, 15 minus 0 times 2, that's your 15, times 15 minus 1 times 2, that's your 13. Okay? So all 3 of these should print out the same thing, right? In fact, I'm going to put the 15 times 13 up ahead so we'll have a little bit of a prep to see what we think our guess is for our answer. So let's do that. Let's say visualize execution. So the first thing it does is sets up this global variable. Now it's going to multiply 15 times 13, which is actually what is supposed to be happening here, right? Because if we start out with n being 15, d being 2, and l being 2, we should have, because the difference between the factors is 2, and there's 2 factors. So let's see here. Oh, I forgot to say print, so it's not going to print it. Let me go back and edit that. So I'll say print here and print here. Okay, so forward and okay, so 195. So this should come back and give us 195. So let's go into repmult. So now we're in our first copy of repmult with n equal 15, the difference being 2, and the length of the or the total number of factors being 2. Okay, so since L is not equal to 0, we're gonna skip that return. Then we're gonna skip this return and go here. So now we have L minus 1. If L is 2, then L minus 1 is 1, right? So this should be, and D is 2. So 1 times 2 is 2, and N minus 2 is 13. So this should be our factor of 13 here. Okay? So we're going to multiply 13 times whatever this turns out to be. Okay? So let's see now what that's going to be. So now we're going to make a new copy. We're going to call a new copy of repmult, but this time we're calling it with 15 and 2 and then L minus 1. So at this point L is 2, so L minus 1 is going to be 1. So let's go into that, and here we are. We're in our new copy. Okay, so now we're working on 15, 2, and 1. Okay. So we still notice. So we still haven't returned anything from this version. up here, right? Because we have to get a return value back from this function before this guy can do his work. Okay? So let's try stepping ahead here. And now since L is 1 at this point, since it's not 0, it's not going to do this return. It's going to go down here. Okay? So at this point, L is 1. 1 minus 1 is 0. 0 times 2, D is 2, so 0 times 2 is 0. And N is 15. So that's going to be 15 times whatever this turns out to be. Okay? But this time, notice, since L is 1 at this point, and we're calling this with L minus 1, L minus 1 is going to be 0. So here's going to be the case where we're going to get a 1 back. So this guy is going to return 15 times 1 back up to this guy, and that guy is going to multiply 13 times that 15. Okay? So let's take a look. Let's see. So we'll go forward. So now we have we're working on our third copy of repmult. Okay? Now notice we started with repmult2. So we really only have we're really only considering 2 factors, right? Which are returned by these guys, or calculated in these guys. But we need this third copy of repmult to say, oh, we're all done. We've got enough. We can just return a 1. So the 1 is basically a way of making sure that our recursion stops at some point and returns a value that that will be reasonable. Because on the 0th case, or on this extra case, really, because this is like a third factor, even though we're only supposed to have 2 factors. If the third factor is 1, that's not going to change what we get for these other, when we multiply 1 with these 2. Okay? So let's see. So let's go forward. Now at this point, L is equal to 0. So we're returning 1. And let's see, it's hard. You can't really see it here. Yeah. So the return value is 1 at this point. So if a 1 gets returned up to this copy, okay, so 1 is getting returned to this copy, but this copy has L equal to 1, right? So in this copy, when we come back to this copy, when we return a 1, so when this guy's going to return a 1, at this point where the 1 gets returned, we've got L equal to 1. So this is 1 minus 1 is 0, times 2 is 0. So this is going to be 15 times 1. So this guy's going to return a 15. Let's see. Okay, so he's returning a 15. Now when he returns a 15, we're going to return that 15 back to this copy. And this is the copy that has L equal to 2. Okay? So in this copy, we're returning this is going to be 15. The result of this is 15. And this L minus 1, or since L it's going to be 2, 2 minus 1 gives us 1 times 2, 15 minus 1 times 2 is 13. So we're going to multiply 13 times the 15. Okay, so let's go forward and return that. And look at that. 13 times 15. When we saw 15 times 13 is 195. Okay, so let's go forward again. And we printed out the 195. And then just one more confirmation. was another way. This was the expanded form, basically, of our 15 times 13. And that's it. Okay? So, I hope that gives you a little more insight. Again, if you want to, if you're having trouble with the concept, I suggest that you work some more examples, try some different inputs for L to see what happens, and also try some different inputs for N and D, just to make sure that you're clear on what's going on with those. So it should be clear to you that, for example, that when D is 3, that the difference between all these factors is going to be 3. 15 minus 3 is 12, minus 3 is 9, and so on. Okay? And that if when N is 10, then all of these things will be 10s. Okay, so you, or basically, if D is 10, you'll start with a 10 and then subtract. If N is 10, you'll start with a 10 and then subtract whatever D is each time. So if this was 10, 3, then we would have 10, 7, 4, and so on. Okay. Okay, and then also, remember how to do all these tests to make sure that whatever you predict the answer should be is what it really comes out to.